Hello, my Intro Chem friends. I hope you're doing well today. Welcome to Chapter 7, which is the last chapter for Unit 2, titled Chemical Reactions. So we've learned in this course so far how to take elements, put them together to form balanced molecules or compounds. We've talked about how to name those compounds. We've talked about how to do some calculations, mathematical calculations with those compounds through the calculation of the mole. Now we're going to talk about how to take these molecules and combine them or react them to give products, aka chemical reactions. So in a normal semester, if we were actually in the lab doing chemical reactions, you would be able to actually see a lot of these indicators that are listed on this slide that are evidences of a chemical reaction. So for example, if you mix two chemicals and you get a gas forming, that is evidence of a chemical reaction. If you get a solid that is produced when mixing two compounds together, that solid, also evidence of a chemical reaction. The formation of a solid or a precipitate is a hallmark of a precipitation reaction, and we're going to talk more about precipitation reactions in future videos. But the formation of a new product, be it a gas or a solid, those are both evidences of chemical reactions, as well as color change, evolution of heat, and evolution of light. So these are all hallmarks of a chemical reaction that you should be familiar with and be able to list for quiz or exam. So those are all evidences of chemical reactions. How do we write chemical reactions? So in the hydrates lab, you had your first chemical equation that was written for you. So we're going to use this example right here to talk about the parts of a chemical equation. So when we write chemical equations, the molecules that are mixed together or that react, they are the reactants, they are written on the left-hand side. Products, or what is formed in the chemical reaction, that is written on the right-hand side. Those are the products. And in between the reactants and the products is an arrow sign. Think about this arrow or this yield sign as like an equal sign. Because when you mix these two things together, what you equal or what you get are the products. Sometimes you will see information written above this arrow that says something about reaction conditions. You won't see that so much in this course. If you go on in chemistry, you will. But those are the main parts of the chemical reaction. Reactants on the left-hand side, products on the right-hand side, an arrow from the reactants to the products. And in many chemical reactions, you will see subscripts in parentheses by each reactant or product to say something about, to say something about the state of matter of that reactant or product. So here's that little star that means that you should know, these abbreviations and what the states are. So for example, if I had H2OG here, that would tell you that is a gas. So these first three are pretty self-explanatory as to what they mean. This fourth one is something that maybe you haven't seen before, but it's going to be very important, particularly when we come to precipitation reactions. But if a reactant or product, if its state is given as AQ, that means aqueous. That means that that substance is dissolved in water. So aqueous is different than liquid. This L means something is a pure liquid. For example, H2O is a pure liquid. If I have something dissolved in that water, for example, sodium chloride, then we would say that sodium chloride is aqueous. Okay. So know these 4 abbreviations and be able to identify the state associated with them when they are listed in a chemical equation. This one doesn't list states, that's okay, because what we're going to use this chemical equation for is to illustrate that the next important feature of a chemical reaction, which is that chemical reactions must be balanced. And so when looking at this chemical reaction, if I was to ask you, is this equation balanced? In chemistry terms, what that means is that if an equation is balanced, that means number and type of atom on the left-hand side has to equal number and type of atom on the right-hand side, or on the product side. So looking at this equation, you can see that, well, I've got 1 carbon on my reactant side, I've got 1 carbon on my product side. So my carbons are balanced, but my hydrogens and oxygens are not. On the left-hand side, I have 4 hydrogens, 4 because of that subscript 4. My product side, I only have 2. So this equation is not balanced, and we have to have chemical equations that are balanced due to conservation of mass. So when we have chemical equations, atoms can't just simply appear or disappear. You have to account for the atoms on both sides of the equation. And as of right now, both the hydrogens and the oxygens are not balanced. So to balance chemical equations, which is what we're going to practice to do in the next 2 videos, to balance chemical equations, how you balance them is by using coefficients. Those are numbers out front of each species in the chemical equation. Coefficients are used to balance chemical equations. You do not change the subscripts when balancing a chemical equation. You use subscripts when putting elements together to form a molecule. Once you've got that molecule formed and it's in a chemical equation, then you use coefficients to balance the overall equation. So that is the take-home message from this little vignette. And the next 2 videos we're going to talk about, and we're going to do some examples of balancing chemical equations.